Locating components for General Electric low-voltage lighting systems, particularly those installed in the 1990s, requires exploring specialized resources. These systems, while once common, often utilize parts that are no longer readily available through standard electrical supply channels. Several avenues can be pursued to find the necessary relays, switch plates, device mounting plates, indicator lights, pilot lit switches, and other related components. Firstly, consider contacting obsolete parts suppliers. These companies specialize in sourcing and stocking discontinued or hard-to-find electrical and electronic components. Examples of such suppliers include Control Devices Incorporated, Electric Replacement Parts, Obsolete Parts Warehouse, RM Electronics, and Surplus Electronics. These suppliers often maintain extensive inventories of older parts and may be able to locate the specific components needed for the General Electric low-voltage system. Secondly, explore legacy lighting distributors. These distributors focus on supporting older lighting systems, including those manufactured by General Electric. They may have access to original equipment, manufacturer parts, or suitable replacements. Examples of legacy lighting distributors include Lighting Services Incorporated, Wattstopper, Diversified Lighting, Leviton, and Lutron. Contacting these distributors and providing them with detailed information about the required parts, such as part numbers and specifications, can increase the chances of finding compatible components. Thirdly, investigate online marketplaces. Platforms like eBay, Craigslist, and OfferUp can be valuable resources for locating used or new old stock components. These marketplaces often feature listings from individuals or companies selling surplus electrical parts. When searching online marketplaces, it is essential to carefully review the product descriptions and images to ensure that the parts are compatible with the General Electric low-voltage system. Additionally, verify the seller's reputation and return policies before making a purchase. In addition to these resources, several other strategies can be employed to locate the needed components. 1. Contact a local electrical contractor who specializes in legacy lighting systems. These contractors often have experience working with older electrical systems and may have access to sources for obsolete parts. They may also be able to provide advice on alternative solutions or modifications if direct replacements are unavailable. 2. Post a request on home improvement forums or social media groups dedicated to electrical work or lighting. These online communities can be a valuable source of information and referrals. Members may be able to recommend specific suppliers or offer leads on where to find the required parts. 3. Check with building maintenance or facility management companies that may have access to older parts. These companies often maintain inventories of spare parts for the systems they manage and may be willing to sell or donate components that are no longer needed. It is crucial to verify the compatibility of any replacement components with the existing General Electric low-voltage lighting system. Before purchasing or installing any parts, ensure that they meet the original specifications and are designed to work with the system's voltage, current, and control requirements. Using incompatible components can lead to system malfunctions, electrical hazards, or damage to the lighting fixtures. Consulting with a qualified electrician or lighting specialist is recommended to ensure proper compatibility and safe installation. When evaluating potential replacement parts, consider the following factors. Firstly, voltage rating. The replacement part must have the same voltage rating as the original component. Using a part with a low voltage rating can cause it to fail prematurely or create a fire hazard. Secondly, current rating. The replacement part must have a current rating that is equal to or greater than the original component. Using a part with a low current rating can cause it to overheat and fail. Thirdly, control signal. The replacement part must be compatible with the control signal used by the General Electric low-voltage system. This includes the voltage level, polarity, and communication protocol. Using an incompatible part can prevent the system from functioning properly. Fourthly, physical dimensions. The replacement part must have the same physical dimensions as the original component. This ensures that it will fit properly in the existing mounting hardware and connections. Fifthly, environmental conditions. The replacement part must be able to withstand the environmental conditions in which it will be used, such as temperature, humidity, and vibration. Using a part that is not rated for these conditions can cause it to fail prematurely. When sourcing replacement parts, it is also important to consider the quality and reliability of the components. Opt for reputable brands or suppliers with a proven track record of providing high-quality electrical parts. Avoid using generic or unbranded components, as they may not meet the necessary safety standards and could potentially damage the lighting system. In some cases, it may be necessary to modify the existing lighting system to accommodate available replacement parts. This could involve replacing multiple components or making changes to the wiring or control circuitry. Any such modifications should be performed by a qualified electrician who is familiar with low-voltage lighting systems. When working with electrical systems, it is essential to follow all applicable safety precautions. Disconnect the power supply before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the repairs or modifications. Low-voltage lighting systems typically operate at 12 volts or 24 volts, which is considered safer than standard 120 volts or 277 volt systems. However, it is still important to exercise caution when working with these systems, as electrical shocks can still occur. Additionally, low-voltage systems can still generate significant heat, so it is important to avoid overloading the circuits or using undersized wiring. When installing or replacing components in a low-voltage lighting system, it is important to follow the manufacturer's instructions and any applicable electrical codes. This will help ensure that the system is installed safely and correctly. Electrical codes, such as the National Electrical Code, provide guidelines for the proper installation and wiring of electrical systems. These codes are designed to protect people and property from electrical hazards. Some common electrical code requirements for low-voltage lighting systems include, firstly, proper wiring methods. Low-voltage wiring must be installed in accordance with the National Electrical Code requirements for low-voltage circuits. This includes using the correct wire size, insulation type, and conduit or raceway. Secondly, overcurrent protection. Low-voltage circuits must be protected by overcurrent devices, such as fuses or circuit breakers. The size of the overcurrent device must be appropriate for the wire size and the load on the circuit. Thirdly, grounding. Low-voltage systems must be properly grounded to prevent electrical shocks. The grounding conductor must be connected to a grounding electrode, such as a ground rod or metal water pipe. Fourthly, separation of low-voltage and high-voltage wiring. Low-voltage wiring must be kept separate from high-voltage wiring to prevent electrical interference and potential hazards. Fifthly, labeling. Low-voltage wiring and equipment must be clearly labeled to indicate the voltage and current ratings. In addition to these general requirements, there may be specific code requirements for certain types of low-voltage lighting systems, such as landscape lighting or swimming pool lighting. It is important to consult the applicable electrical codes and regulations before installing or modifying any low-voltage lighting system. When troubleshooting a general electric low-voltage lighting system, it is important to start by checking the power supply. Ensure that the power supply is providing the correct voltage and current. If the power supply is not working properly, it may need to be replaced. Next, check the wiring connections. Ensure that all connections are tight and secure. Loose or corroded connections can cause voltage drops and system malfunctions. Also, check the wiring for any signs of damage, such as cuts, abrasions, or melted insulation. Damaged wiring should be replaced immediately. If the power supply and wiring connections are good, the next step is to check the individual components. Use a multimeter to test the voltage and current at each component. If a component is not working properly, it may need to be replaced. Some common problems with low-voltage lighting systems include, firstly, lamps that do not light. This could be caused by a burned-out lamp, a faulty ballast, or a problem with the wiring. Secondly, flickering lamps. This could be caused by a loose connection of faulty ballast or voltage fluctuations. Thirdly, lamps that are too dim. This could be caused by a voltage drop, a faulty ballast, or an undersized power supply. Fourthly, lamps that burn out quickly. This could be caused by overvoltage, excessive heat, or a faulty ballast. When diagnosing problems with a low-voltage lighting system, it is important to have a good understanding of how the system works. This includes knowing the voltage and current ratings of the various components, as well as the wiring configuration. It is also helpful to have a schematic diagram of the system. If you are not comfortable troubleshooting electrical systems, it is best to hire a qualified electrician to perform the repairs. Maintaining a general electric low-voltage lighting system can help extend its lifespan and prevent problems. Some simple maintenance tasks include firstly cleaning the lamps and fixtures regularly. Dust and dirt can accumulate on the lamps and fixtures, reducing their light output. Secondly, replacing burned-out lamps promptly. Burned-out lamps can put a strain on the other components in the system. Thirdly, checking the wiring connections periodically. Loose or corroded connections can cause voltage drops and system malfunctions. Fourthly, inspecting the power supply for signs of damage or wear. A faulty power supply can damage the other components in the system. By following these simple maintenance tips, you can help keep the general electric low-voltage lighting system running smoothly for years to come. When replacing components in a general electric low-voltage lighting system, it is important to use the correct replacement parts. Using incorrect parts can damage the system or create a safety hazard. The replacement part should have the same voltage rating, current rating, and wattage as the original part. It should also be compatible with the system's wiring and control circuitry. If you are not sure which replacement part to use, consult with a qualified electrician or lighting specialist. They can help you identify the correct part and ensure that it is installed properly. In some cases, it may be necessary to upgrade the existing lighting system to meet current energy efficiency standards. This could involve replacing the existing lamps and fixtures with newer, more efficient models. It could also involve installing a lighting control system that automatically adjusts the light levels based on occupancy or daylight availability. Upgrading the lighting system can save energy and reduce operating costs. It can also improve the quality of the lighting and create a more comfortable and productive environment. When considering a lighting upgrade, it is important to work with a qualified lighting designer or engineer. They can help you evaluate the existing lighting system and develop a plan for upgrading it. They can also help you select the appropriate lighting products and ensure that the system is installed properly. Low-voltage lighting systems can be used in a variety of applications, including residential, commercial, and industrial settings. They are often used for task lighting, accent lighting, and landscape lighting. Low-voltage systems are also used in specialized applications, such as medical lighting and theatrical lighting. The advantages of low-voltage lighting systems include firstly, energy efficiency. Low-voltage lamps typically use less energy than standard voltage lamps. Secondly, long lifespan. Low-voltage lamps typically have a longer lifespan than standard voltage lamps. Thirdly, safety. Low-voltage systems are considered safer than standard voltage systems, as the lower voltage reduces the risk of electric shock. Fourthly, versatility. Low-voltage systems can be used in a variety of applications. The disadvantages of low-voltage lighting systems include firstly, higher initial cost. Low-voltage systems typically have a higher initial cost than standard voltage systems. Secondly, requires a transformer. Low-voltage systems require a transformer to step down the voltage from the standard voltage to the low voltage. Thirdly, limited distance. Low-voltage systems are limited in the distance that the wiring can run. When designing a low-voltage lighting system, it is important to consider the specific requirements of the application. This includes the desired light levels, the type of lighting fixtures, and the wiring configuration. It is also important to consider the energy efficiency and safety aspects of the system. Working with a qualified lighting designer or engineer can help ensure that the system is designed and installed properly. Low-voltage lighting systems are a versatile and energy-efficient lighting solution. They can be used in a variety of applications and offer a number of advantages over standard voltage systems. However, it is important to consider the specific requirements of the application and to work with a qualified lighting professional to ensure that the system is designed and installed properly. When searching for replacement parts for a general electric low-voltage lighting system, it is important to be patient and persistent. It may take some time and effort to locate the required components. However, by following the strategies outlined above, you can increase your chances of finding the parts you need to keep the system running smoothly.